Alright, so here's the Maggie Penguin 2D collision momentum problem. Since there are two dimensions, the momentum is conserved in both, in the x dimension and in the y dimension. I'm going to use both and simultaneous equations substituting in to solve. I'm going to begin with the y direction because I see that there is no initial momentum in the y direction. It's moving perfectly horizontally. So that means that the momentum in the y direction final is going to have to sum to 0 because of conservation of momentum. The momentum of Maggie minus the momentum of the penguin is going to have to give me 0. I substituted in m and v for p, remembering that I'm in the y direction and I'm final. I've gone ahead and I've used trig. I can't bring the y over here into the x direction, so I have to get rid of the y. I get rid of the y by using trig. Vyp final is going to equal Vp final, put a little f here, sine theta p, Vy, Vmf, sine theta m. Alright, I fixed that little subscript. And I brought this and this down here, and I left that as it was, and I got an expression for Vm final that I will be able to bring over to here because there's no longer a y in it. Before I do that though, I'm going to put numbers in here because I have numbers for all of these, and I don't want to drag these around as variables any longer. So let me go ahead and do that. Substituting in for this, that, and that, I got 0.69, this I didn't know, Vp final, and Vm final. Now I'm going to go over to the x and set up an initial momentum and a final momentum. Initial momentum of Maggie. There is no initial momentum of the penguin. Final momentum of Maggie in the x direction. Final momentum of the penguin in the x direction. I want to use trig to get rid of these x components. I've substituted in for the x component, I've substituted in for the y component, and I hope you see where I'm going. I'm going to take this now, I'm going to bring it over here so that I can get rid of the Vm final, and I'll only have Vp finals in this expression. I'll have everything, and I can solve. Plugging in, left this the same, I put in here, same, all the same. Now I'm going to fill in the numbers I know and solve for Vpf. Substituting in, the only thing I don't know is Vp final, and when I solve for that I will find out that Vp final equals 3.1. Then I'm going to go back to this expression right here, put in 3.1 for Vp final, and I'm going to find out that Vm final is 2.1.